Okay, a nurse at a local hospital is interested in estimating the birth weight of infants. How large a sample must she select if she desires to be 99% confident that the true mean is within 2 ounces of the sample mean? Standard deviation of the birth weights is known to be 7 ounces. Okay, so we are looking for how large a sample must she select. So that is the sample size. That's what we are looking for. So n equals something. And our confidence level is going to equal 99%. And our confidence interval is going to be within 2 ounces of the sample mean. So sample mean minus 2 ounces, and our sample mean plus 2 ounces. So we're 99% confident that the true mean of the population is going to be within 2 ounces of our sample mean. And we know that the standard deviation for the population is going to be 7 ounces. So how do we find our sample size to produce this interval? The equation for our interval is usually our sample mean minus our margin of error to our sample mean plus our margin of error. And the margin of error is going to equal our critical point, our critical value, which is designated this way, times the population standard deviation divided by the square root of n. To find z sub a over 2, that is, if you look at a graph, confidence level is 99%. That means that the area surrounding the mean is equal to 99%, which means the area of the two tails added together, that's A, is going to equal 1 minus 0.99. So A equals 0.01. And our z of a sub 2 is going to be this spot right there. And this is a standardized normal distribution where mu equals 0 and our standard deviation equals 1. So this value for z is just our z-score. And we're going to use our calculator, in this case a TI-83, to find z sub a over 2. And to do that, the function we're going to use on our calculator is the INV norm function. And we're just going to put one number in there, and that is our confidence level, 0.99. Now, when you don't put any other numbers in there, it's just going to assume that you're using a standardized normal distribution where mu equals 0 and the standard deviation equals 1. Otherwise, you'd have to put the mean and standard deviation in there also separated by commas. But when you don't do that, it just assumes the mean is 0, standard deviation is 1. And that's what we want to, in order to just get our z-score for a over 2. Actually, you have to do a little trick. You can't just use the confidence level. You have to use a little trick here. So we do have to know what a is. So a is the sum of these 2 points, and just to find this point here, we need a over 2. So that's 0.005. And that's the number we're going to use here, 0.005. However, that's going to give us the negative z-score. So to find the positive one, we're going to take the negative of that INV norm. So negative, and let's see, to get to that INV norm, you hit the yellow second button, go to the vars button, and select number 3. Punch in 0.005, close the parentheses, and I get 2.57, and we'll round it to the third decimal place, which is 6. Okay. So now that we have that, we can solve for n, which is what we were looking for in the first place. But we're going to have to rearrange our equation for the margin of error. So I got to start moving some variables over here to this side of the equal sign in order to isolate that n. So first thing I want to do is, well, I could re-express this in a way that's visually easier to see what I'm going to do. We got z sub a over 2 times sigma, and we're going to divide that whole thing by the square root of n. So this is the same thing as that. And when you're dividing by a variable, and that's the variable you want to find, all you have to do is take the numerator and divide it by what's on the other side of the equal sign. So z sub a over 2 times standard deviation divided by e is going to equal the square root of n. So that means if I just square both sides, n will equal z squared times standard deviation squared divided by the margin of error squared. So let's write that back up here. So n is going to equal, let's put that z sub a over 2 in parentheses to help see the square. Multiply that by the standard deviation squared, and we're going to divide by e squared. And e is this right there, 2 ounces, based on this equation. So let's see, what was our z sub a over 2? That was, so this is going to equal 2.576 squared times our standard deviation of 7 ounces squared. And we're going to divide by 2 squared. Okay, and what does that equal? 2.576 squared times 7 squared divided by 2 squared. I get 81.29 rounded to that second decimal place. Oh, but this is a sample size, so it's going to have to be a whole number. So we'll just round it to 81.